For topic 2, we're going to look at adding rational expressions that have a common denominator. So remember, as long as you have a common denominator, you just add or subtract your numerators, keep your common denominator. Same thing is going to be true with rational expressions as what we did with fractions. So if we have two expressions, P over R and Q over R, then P over R plus Q over R is just going to be P plus Q over R. We do have to make that assumption that R cannot equal 0. So always remember your denominator can't equal 0, okay? But the same thing is true in here, or in this example, as what we did in the previous topic. We looked at just dealing with adding fractions with a common denominator. You add your numerators, you keep your common denominator, and then you simplify. The same thing is going to be true here. We want to add or subtract our numerators. So in this case, we're dealing with adding rational expressions. So we're going to add our numerators. We're going to put that over our common denominator, and then you have to simplify. But remember, simplifying with rational expressions means you factor first, then you divide out common factors. Okay, so let's go ahead and just look at these examples here. So example 2 says find each sum. Well, we have to always remember this is going to be completely different than multiplication and division. With multiplication and division, we start out by factoring everything and then simplifying and then doing the multiplication. Not the same here. We want to make note, do we have a common denominator? If so, keep moving. You add or subtract your numerators. In this case, we're adding, so we want to just add across. We want to combine like terms. And then at the end, we do the factoring and the simplifying. Okay? So for this one, we have 3x squared plus x, plus we want to make sure we add this entire numerator, and all of that goes over our common denominator. Okay? Now, technically, you have to go back to this idea of adding and subtracting polynomials that we talked about in a previous chapter. When you're adding and subtracting polynomials, you're technically having to remove parentheses. So you have to think of these two numerators as two separate polynomials. And in order to add them or later subtract them, we have to drop the parentheses. Well, in order to drop those parentheses, we really technically have to distribute a 1. Okay, so we distribute a 1, and that gives me 3x squared plus x plus 2x minus 2x squared all over x squared minus 9. We want to simplify our numerator completely, so that means combining like terms. Well, if I look here, I have x squared terms, and then I also have, let me get a different color. I also have just x terms. So let's combine our x squared terms, then we'll combine our x terms and see what we have. So looking at the numerator, I have 3x squared minus 2x squared. That's just 1x squared. And then x plus 2x is 3x. And then my denominator is still x minus 9. It's at this point that you want to factor. So we've already done a good bit of work before we even thought about factoring, okay? So let's bring this all the way over here to the top. So I've got x squared plus 3x all over x squared minus 9. Well, in the numerator, I can factor out a GCF of x. Both of those terms in the numerator have an x in common, so I'm going to get x times the quotient after I divide the GCF. So x squared divided by x is x. 3x divided by x is 3. Now, my denominator, hopefully you're getting better at recognizing things. My denominator, I notice my first and second term are both perfect squares. I notice that I'm subtracting, so that would be the difference of perfect squares. So here I would take the square root of x squared and the square root of 9. So that would be x and 3. I would add the square roots, then I would subtract the square roots. All right, so we factored that common denominator. And now, finally, at the very end, we look to see if we have any factors that could divide out. And we do. I notice an x plus 3 in the numerator and an x plus 3 in the denominator. X plus 3 divided by itself is just 1. So that leaves me with 1 times x in the numerator and 1 times x minus 3 in the denominator. So that is my final answer, okay? So you have to understand the steps that you take with multiplication compared to addition and eventually subtraction. With multiplication and division, you write everything as multiplication, factor immediately, then cancel, then multiply. Here, we do all the addition first, put it over that common denominator, and then at the end, we factor and simplify. So make sure you understand the different steps you take for the different operations, okay? Next up, let's look at part B. So for part B, we do have common denominators. The common denominator is 2x squared minus 7x minus 15. Our numerators need to be added, so you have to remember, and this is especially important with subtraction, but I want to get you into the habit now. We have to add two polynomials, okay? So what we're really doing is we're taking those two polynomials, two x minus 2 and 5, and we have to add those and put them over the common denominator of 2x squared minus 7x minus 15. Well, the thing you have to always remember is when you add two polynomials, you have to remove those parentheses by really just distributing a 1. And this is going to be so much more important in the next video, but I want to make sure you kind of see it here. So when you distribute a 1, nothing happens. So 1 times 2x is 2x, and then minus 2, and then plus 5 all over that denominator. Well, in the numerator, I can combine like terms. So that's going to be 2x plus 3 all over 2x squared minus 7x minus 15. So that denominator is going to require some work. It is a quadratic trinomial, but the coefficient on the squared term is not 1. So we have to do the AC method. And there's nothing wrong with the AC method. It's just more time consuming. So A is the coefficient of the squared term, which is 2. C is the constant, which is 15. So we're looking for factors of negative 30 that have a sum of negative 7. Okay, so when we have a negative product, so 30 is a negative product, or negative 30 is the negative product I'm referring to. We need to find two factors of that number, but they have to have different signs. So one has to be positive, one has to be negative. We need them to have a sum of negative 7. In order to have two numbers with different signs have a negative sum, the bigger of the two numbers needs to be the one that we make negative. So when we look for factors, we could look at negative 30 and 1, negative 15 and 2, negative 10 and 3, or negative 6 and 5. One of those pairs of factors has the sum that we want, and it just so happens to be negative 10 and 3. So what we do is we rewrite our polynomial, but instead of writing negative 7x, we're going to break negative 7x into the sum or difference of two terms, and those terms have the coefficients that are the same as the factors we just found. So I'm going to write this as negative 10x plus 3x minus 15. So I've broken down that negative 7x into the sum of two terms. Now I factor by grouping, which just means I factor the left and then the right and then factor overall. So looking at the left, I have a GCF of 2x. When I divide both of those terms by 2x, well, 2x squared divided by 2x is x. Negative 10x divided by 2x is negative 5. The second two terms have a GCF of 3, so I'm going to write down a plus 3. When I divide by 3, 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. I hope you can see that we have this x minus 5 in common on both halves of this polynomial. So I end up with x minus 5 times 2x plus 3. So we have 2x plus 3 in the numerator. My denominator is now x minus 5 times 2x plus 3. Oops. So hopefully you can see here that we have a common factor of 2x plus 3 in the numerator and in the denominator. So 2x minus 3, or wait, 2x plus 3 divided by 2x plus 3 is just 1. So that tells me my final answer is 1 over, well, the denominator is just x minus 5. So that becomes my final answer, okay? So be really careful with this step. Let me mark it in red. Be really careful with this step right here. Showing this step with addition is not that big a deal because when you're adding two polynomials, you just add all the terms. You combine all the terms. But in the next video with subtraction, that step's going to be a bit more important. You have to be really, really careful there, okay? So make sure that you have practice adding rational expressions. Next video, we will talk about subtracting.